Welcome guys. So let's move to the last part of anonymous inner class, and that is using lambda expression. Now let's see what exactly lambda means. So before starting with lambda, let's change this code a bit. Now if you know, in Java we have something called as interface. Now let's say if I make this b as interface, that means it should be small I. If I make this class as this b as interface, that means I cannot define methods here. I just have to declare it. Okay. So what I have done is, in fact, all the methods in interface are public abstract. So I have an interface called as B, and here what, let's say I want to create instance of B. Okay. So how to get instance of B is we have to say B obj equal to new B. But unfortunately, interface cannot have a instance, so we cannot create an instance of an interface directly. For that, we have to create a class. Let's say class name is xyz, and this class should implement b, so that when you create object of this xyz, again you have to define a method here which is public void show. Again, there should be some logic in this code here. But let's say I have a class xyz which implements this show. That means I can create a instance of xyz so that I will get an instance of b. Clear? That's one way. The another way of creating this class is using inner class. So what I mean by inner class is, the problem is when you create an instance of b here, b will simply say I'm an interface and I don't have the implementation. So here this part will say, okay, you don't have an implementation, but hold on, I can implement b interface here. Okay. So, and b interface has only one method called as show, so we can directly implement it as public void show. Okay, and we can simply say it will print hello. So now if I call obj.show, it will go for this implementation and it will give the output as hello. Okay, that's one way of defining a interface. Now if we focus on this code, we have an interface which is just it just has one method, and this type of interface in Java is called as SAM, which means single abstract method interface. Okay, and this thing used to be called in 1.7. But in Java 8, there is a concept of functional interface, which means an interface which has only one method can be called as functional interface. And to specify this as a functional interface, we can use an annotation called as functional interface. Okay, which means you can have only one method. What if I define one more method which is ABC here? And you can see it will give me an error. It says functional interface should have only one method. So that means ABC will not support here. Either you need void show or ABC. Now since you are working with functional interface, if I jump to this functional interface, it will specify that this functional interface concept was launched in Java 1.8. Now the advantage of using functional interface is, using functional interface you can just remove some boilerplate code. Now what it means, now see, when you create an instance of this b here, so it's for sure that after this line there should be an instance of b, and that means there should be compulsory, there should be new b, and then there is obvious thing that this interface has only one method which is show. So that means this line should be show. So why, as a programmer, we are writing this code? What if we ask our Java or JVM to implement that thing for us? What I mean is, we need to say this instance, this interface B, which has a reference called as obj, has a method called as some method. You search it, I don't know which method, but you search it. There is a method with the default signature which is blank signature. So you can see we have a blank signature, and in this method I want to implement something. So I have to implement, that means I have to send something. So we have to use this arrow, and we have to give curly brace open and close and a semicolon which specify this. Let me write it here only. Okay. So I can simply say a bracket and then this semicolon. That means the implementation inside show will be here. So let me just give the enter and we'll say the implementation what I need is just hello, simple, right? So this is also an anonymous class. Okay, it's kind of anonymous class where you are defining a lambda expression, and if you run this code, it still works. You can see it's hello, right? And that's the advantage of Java 8 of Lambda expression. You can remove the boilerplate code. Then you will say, okay, that means we are just removing the boilerplate code. That's it. There's no performance improvement. Let's focus on this class now. If you refresh this page or refresh this file, you can see we have only two classes. One is B and inner demo. This B is the interface class bytecode, and this is inner demo bytecode. Where is the inner demo $1? No, it's not there. It's because JVM is so smart that it says for Lambda expression, I know this is a kind of anonymous class, but I will not create an anonymous class of it. And it's that efficient, right? And now what you can do is, if you know in your block you have just one statement, that's then you don't require this curly braces. You can directly specify the statement here, and you can write the whole statement in one line. So we can say it is system.println, and here we can give the semicolon. So this is how you can use lambda expression. So a point to remember when you talk about this lambda expression, it only works with functional interface. Okay. So there are lots of advantages of functional interface. There is something called a stream API which works with functional interface. What's stream API? What functional interface? That might be in my next video tutorials. So that's it from inner classes, which are member class, nested class, anonymous, and lambda. Okay, and that's it from the inner class session. For next set of tutorials, do subscribe and thanks for watching.